Everybody, good afternoon to all of you. Welcome to this live session on the massive open online course on solid fluid operations. So I think you have already gone through the various lectures till now, whatever covered. If you have any doubt on these lectures, even if you are not able to understand some portions of your lecture, then please write to us, or you can ask here so that you can uh, clarify those doubts. So are you there? I think you are there anyway. You are coming, and some of your friends are joining here. So again, that in this course we discussed various topics like particle characteristics, particle size distribution, even particle size enlargement, particle size reduction, their method, even how that particle size can be utilized for various chemical processes, especially for catalyst particles if it is used for chemical reactions. Then you have to know the characteristics of the particles. There we have discussed something characteristics of the particles like particle size distribution, mean particle size, what is the surface area of the particle size. Even we have discussed that how actually that particle size distribution can be represented. What is the shape of the particles that we have discussed? What are the basic parameters that you are considering for analyzing the shape of the particles? Even I think we have discussed that special phenomena of the particles like fluidization operations, where that various applications with the solid and fluid, especially in the petrochemical industries, when converting that various products from the gaseous products to the liquid products, even from the synthesis gas, how various products of the petroleums, even different fuel, light fuel oil, kerosene, heavy fuel oil, even naphtha, even kerosene, all those products, how can be produced by the fluidization operation. It was discussed, and for that, what are the different catalyst particles are used. That also discussed in the lecture, and for that you have to have a specific characteristics of the particles like that the sphericity of the particles, particle outlines, specific surface area of the particles. So all those things were discussed in the lecture. I think you have gone through those lectures, fluidization operation, froth rotation system, even fluid flow through the porous media, even how the particulate materials, if it is very finer, how it can be separated from the mixture of the particles, what are the different methods for separating those particulate materials. Those have been discussed in the lectures. I already discussed all those phenomena in the lectures. Please go through those lectures once again. If you have any doubt on the lectures, you can ask here itself. Even if you are not here, you can ask in the forum, or you can directly mail to me so that I can clarify those doubts here. So also that we have discussed various topics about that, filtration processes, microfiltration, nanofiltration, even macrofiltration. That macrofiltration are various types of those macrofiltration, like I think plate and frame filter press we have discussed, even rotary drum filter we have discussed. What are those basic principles of filtering those particles from the slurry? Those we have discussed. Please go through those phenomena, even that principles, and also for those principles that how that particles are interacting with the other particles, that also were discussed. And also we have discussed that frictional resistance of the particles with the fluid, whenever fluid which is flowing through the porous media, even in packed bed systems, when fluid will be flowing through the bed of particles, then how the interfacial area, even that frictional resistance will be important to assess those processes. How that frictional resistance can be calculated, what will be the frictional pressure drop, even what will be the friction factor that we have discussed in the argon equation. Even we have discussed those can be calculated by the cosine carbon equation. There will be a certain range of those equations to be applied. Even what are the different components of the argon equation, whether this flow will be viscous dominated or inertia dominated, based on which that total frictional resistance, how it can be calculated by the argon equation we have discussed. So again, that you have to go through those principles of that porous media flow, even what will be the different factors that affecting on that frictional resistance whenever fluid will be flowing through the porous media. How that porous media will be useful for application of different chemical processes, like when that gas and liquid flowing through that packed bed in downward flow motion. What is the advantage of the downward flow motion of that gas and liquid? Whereas if we use that gas and liquid counter currently, what is the disadvantage in that packing materials? Even if we use that co-current downward, what are the advantages? Especially we have discussed in this course, like trickle bed reactor, that is also packed bed reactor, where gas and liquid is flowing from the top to bottom in the downward directions, that is in the direction of the gravity. There you will see that advantage is that there should not be any back mixing when gas and fluid both will be flowing concurrently in the downward directions. Whereas if you are using that flow in the upward directions, there may be that internal circulation will happen, because of which there will be a back mixing phenomena. And due to that back mixing, there will be a disadvantage of that reactions yield. So in that case, the trickle bed will be advantageous. Whereas other bed also is advantageous, like fluidized bed reactor. Their particles will be flowing inside the bed as like a fluid. So in that case, all the particles will become in contact with the gaseous or fluid medium, so that interaction of the particles with the fluid will be more. So more interaction may give you that contact of surface between solid and gas or liquid. So in that case, there will be some advantages of using this fluidized bed reactor compared to the packed bed reactor. So all those phenomena were discussed in this lecture. So if you have any other doubt, please ask here. Okay. And also special topics that we have discussed in this lecture, that is I think adsorption phenomena of the solid particles, whether gas or liquid to be adsorbed on the solid surface, what will be the basic principles of adsorption, and what are the different, mechanism of adsorption, and what are the different isotherm, and also what are the kinetics of that adsorption that we have discussed in the, last three lectures, that is, last modules there. So it will be very useful for you, even those who are interested for higher studies. For them it will be very useful. In another module that we have discussed something about that nanoparticle, how that nanoparticles are defined, how that nanoparticles are characterized, how that nanoparticles, that useful for different applications. What are the different properties of nanoparticles that we have discussed? Even that, how that nanoparticles can be synthesized. There are two methods, like, physical methods and, chemical methods. Those two methods were briefly discussed in this, module. I think it will be very useful for you, again, those who are interested in higher studies also. Even nowadays, that nanoparticles are being used in various applications, either in chemical or non-chemical processes there. You'll see that to get that more interfacial area, even that interaction of the particles, there will be certain advantage of these nanoparticles for specific applications. Those has been, discussed in the application part of this, lecture in the module. I think it is in 11th module we have discussed about that nanoparticles. So this course has been, devised in such a way that you have to first go through that characteristics of the particles of the macrons, macro size, or you can say that micro or micron size also. In nano size, that also are discussed here. So what are the different properties, different characteristics that has been discussed? Also, uh, later on that how that nano size particles can be, used so that it can be, enlarged for a specific purpose to get a certain, product. So in that case, to get the certain products and its stability and its strength wise, product to be, resize of this, based on this particle. So even based on the, applicability. So based on which that enlargement, of the particles, that is very important. So what are the different methods of enlargement of particles? That is size enlargement of the particles, different methods, different equipments, those are being used, those are discussed in a module. Then we have discussed, I think, what are the, methods of, size reduction. You'll see that sometimes in coal industry or other material synthesis, or even other material process industries, they will have that, materials directly from the, natural sources, and from those natural sources you'll see that the particles will be bigger in size. So to apply those particles into a particular process, you'll see that you have to reduce that particle size into a certain, size. So to get that reduction of the particles, you have to use certain method. So what are those methods that also are discussed? Even what are the different equipments are being used for reduction of the size of the particles? I think we have discussed there, like jaw crusher, that different mills, roller mills, roll crusher, even other different type of devices that we have discussed. And for reduction of the size, there will be certain principle that you have to follow, and based on the principle, you will see that whenever particle size will be reduced, there will be a certain amount of energy to be, dissipated, or certain energy to be consumed. That energy, how can we, calculated, what is the basic principle of energy, consumption of that size reduction, that has already been discussed. There are three different principles for energy consumption calculation. I think we have discussed in the lectures, like, Kick's law, Rittinger's law, even, Bond's law. These are three laws are very useful to calculate the consumption of energy for the size reduction. Even we have discussed different, basic principles of, roll crusher, even jaw crusher, what is the capacity, even what are the, minimum, size of the, roll gap, or even angle of nip. All those things have been discussed in the lectures. So please go through once again all those lectures. Even if you have any other doubt here, you can ask directly in the forum, as well as you can directly contact with me with the email address that is given at the end of the lecture. And also we have discussed something about that, separation of the particles. There are different methods of separation of the particles, and for them, what are the different equipments are being used for that separation process already we have discussed there. Sometimes you that in industry, sometimes electrostatic precipitator are being used for the separation of the particles. Even gravity settler, that are those are being used for, separation of the particles. Even back filter, lip filter, all those things are being used in the industry for the separation of the fine particles. In liquid solid system, to separate those particles, I think we have discussed that lip and lip filters. Even we have discussed about that plate and frame filter press, even a drum, rotary drum filter. So those, equipment or devices are very useful for the separation of the particles from the slurry. So we have discussed their principles, capacity, advantage, disadvantage, all those things in the lectures. Please go through once again. If you have any other doubt, you can ask here. Please ask here. Even we have discussed in the, course with ample of examples, especially, the, the pattern of that, questions, those are, coming in gate examination. I think you have heard about that, gate examination. That means after completion of, engineering degree, after 4 years or 3rd years onward, that those were appearing final year also, they are, eligible to, appear for gate examination. And in that, gate examination, you will see that you can expect the questions like this type of questions, whatever we have discussed in the, lectures. And I think in the gate syllabus, this, solid fluid operations or mechanical operations, it is specially named. So mechanical operations is basically the solid fluid operations there itself. You can, get all those get type of questions here in the lectures. So this course is made based on that, gate syllabus also. Even we have discussed the pattern of the questions. Those are, coming in, gate examination. So please go through those examples also. In each lectures, I think wherever possible and whatever, possibility of the questions that can be made as per gate pattern we have, given. So please go through those questions and then try to understand. Even if you have any other doubt on these questions, even if you are not able to, solve those questions, you can write to me directly. We can give the answer to you. Okay. Hello. Anybody else? Anybody any questions? Yeah, please come forward if you have any doubt. Anybody? Anybody have any queries regarding this? Please ask here. So I think you have started your the module. I think this basic understanding of of fluidization and application of fluidization. So then this module, I think we have discussed about that. What is the fluidization? How that fluidization principle can be applied for different chemical processes there. We have discussed even after that what will the minimum flow condition to be maintained to get the particles fluidized in a reactor or conduit or in a system. So in that case, we have discussed that what is the minimum fluidization velocity, and beyond that minimum fluidization velocity, you will get different flow patterns of the fluidization. So what is that fluidization? I think we have discussed that this is basically a process by which a bed of solid particles, is converted from a static solid-like state to a dynamic fluid-like state by means of a flow of fluid. Fluid means gas and liquid or gas-liquid mixture. And also we have discussed that this is basically multi-phase systems. So in fluidization may happen, gas solid system, liquid solid system, and gas liquid solid system also. So we can divide this fluidization into two category. One is two-phase fluidization, another is three-phase fluidization. Where phase is basically with the interaction of gas solid and liquid solid system, and that will be two-phase fluidization. So, and three-phase fluidization, they are gas, liquid, solid. Three phases will be, getting interaction to each other. So gas or liquid, there you'll see that acts as a continuous, or solid acts as a discrete or dispersed phase there. So in that case, this fluidization, basically the discretization movement of the, or discrete movement of the solid particles in a gas or liquid medium. Now that, why does that fluidized bed behave like a fluid? That also we have discussed. In this case, this is basically the same principle of that liquid, which will be, holding a container, and how that liquid will be, behaving there. So in this case also, when the particles will be fluidized or suspended in a liquid or solid, liquid or gas medium, in that case, this, fluidized bed will seek its own level. That means bed height would be there. Even objects with a lower, density, then the bed density, you will see that will float on its surface, and bubbling up and down it, if pushed downwards there. And then beds have a static pressure head due to gravity. Even you will see that in the fluidized bed, levels between two similar fluidized bed equalize their static pressure heads there. And also, if your height of the bed will be increased, in that case, hydrostatic pressure also will increase. So according to that, fluidized phenomena will be utilized for getting more contact between gas and liquid and solid. And there you will see that to operate, I told already that there should be a minimum fluidization velocity to get that particle suspended in the bed. And it depends on that particle terminal velocity. If you are having the gas velocity more than terminal velocity, you will see that particles will try to go up, or it may be suspended under the action of that gas and liquid flow. So in that case, there should be a minimum velocity. That means at its minimum, condition that where terminal velocity will be, equals to the gas velocity there. In that case, particles will get the suspended. If it is only one particles, even if there are more than one particle or mass of particles, in that case, you will see that what would be the frictional resistance that is, incurred by that solid mass with the wall of the bed, that should be equals to the, drag force exerted by the frictional resistance exerted by the, solid bed with the wall, or among the particles, or between the solid and, gas. So in that case, from that, post balance, you can get what would be the minimum, fluidization condition that we have discussed. From the backed bed condition, beyond which that, if there are more frictional resistance, then what will be the minimum velocity? How can be calculated from the Argon equation that we have discussed there. So beyond that fluidization velocity, minimum fluidization condition, it is also called that incipient fluidization. So beyond that, the incipient fluidization or minimum fluidization, you will have different type of flow patterns of the fluidized bed. Okay, what are those different flow patterns? You will see that initially it will be intact, that is fixed bed condition. Beyond that, there will be minimum fluidization condition. That means in that case, particulate material or particles inside the bed will be getting just suspended. So it will be called as homogeneous fluidization. Okay, and beyond that homogeneous fluidization, beyond that gas velocity of this homogeneous condition, you see that inside the bed there will be a formation of bubbles. That means some void fractions will be produced there. There will be a chunk of, particles will be distributed in such a way that there should be some gap formation, and that gap will be a certain, shape. So that is called bubble. So in that case, beyond this homogeneous fluidization condition or minimum fluidization condition, there the formation of bubbles will be there from the distributor plate of the gas. That means gas or liquid to be distributed through the bed of the solids through a gas distributor. So that gas distributor will, in that region of gas distributor initially, that some bubbles will be forming. Those will be very smaller in size, whereas when it will be going upward directions, those gaseous, gap, what it is called bubbles, will be interacting to each other and making a coalescence and forming a bigger bubbles, and it will be going upright to the surface, and then in the surface it will be burst out and collapse that bubbles. And this way you will see that continuously bubble formation inside the bed, and it will be rising at a certain velocity, and then it will be collapsing on the surface. So this type of phenomena, it would be called that bubbling fluidization. And there should be minimum, gas or liquid velocity to be maintained so that that bubbling formation would be there inside the bed. So this is one type of bubbling phenomena. And then, slugging. And beyond this bubbling phenomena, you will see that if the size of the column will be reduced, then you will see that some bubbles will be forming in such a way that at least 66% of the column diameter will be occupied by that bubble. So in that case, you will see the bubbles will look like a, bullet shaped bubbles, or you can say that, that flat bubble, those will be, going up in the central core region of that, bed. So in that case, this phenomena it will be called as slugging, fluidized bed or slugging flow pattern. Even after, if you increase the gas or liquid velocity inside the bed, you will see that the bubbles will not be a particular shape. There will be a, breaking of that bubbles, and some bubbles will be, elongated, and that will be very irregular in shape. Some will be some long, even some will be, laterally, elongated. Some will be vertically elongated. Some will be broken into very finer ones. So in that case, irregular shape bubbles will be there. Even you will see that those, bubbles will not be a particular fashion that will be forming inside the bed, and movement also will be random. So this type of phenomena will be called as, churn turbulent flow pattern. And beyond the churn turbulent, another flow pattern it will be called fast fluidization. So there itself, neither that longitudinal or flat or axial bubbles will be forming, but there you will see that uh, 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 there will be a, huge, uh, uh, gap of these, particles and particles, and they are, more wide fraction inside the bed that will not form any bubbles inside the bed. Whereas there will be a void inside the bed that will be continuous void, and, it is called that cyclone separator. Uh, and by that cyclone separator, those particles will be recovered and again used, reuse after regeneration or its activity, and then continuously operating the fluidized bed and reusing that solid particles inside the bed. This type of phenomenon it is called fast fluidization. Beyond that fast fluidization, you will see that the terminal velocity of the particles will be, very, very less than that, gaseous velocity. That means you can say that if gas velocity or liquid velocity is 20 times greater than particle terminal velocity, in that case, there should not be any, bubble formation. There will be, particles, dilute phase particles will be moving inside the bed, or transporting that particles from the bottom to the, top of the bubble, just like a liquid flowing or gas flowing there. So in that case it will be called as pneumatic transport. So for transporting the solid particles, this type of, fluidization happens. It is called pneumatic transport pattern of the fluidized bed. So these are the different, flow pattern of the fluidized bed. This flow patterns formation depends on different factors, like, size of the particles, size of the column, even distributor type, even gas velocity or liquid velocity, even you can say that type of the, or classification of the particles. We have discussed in a lecture what are the different classification of the particles. I think we have discussed that Gildert, you know, particle classifications. There are four types of particles are there based on the size and their, relative density of the particles with the fluid. So based on which I think we got that C, A, B, D type particles, four types of particles we, observed there. Okay, that is cohesive nature particles, where particle size will be less than 30 micrometer. Even we have discussed that other type like A type particles, aerated, where the bulb, just the white fractions will be their formation. And also we have discussed that B type particles, they are bubbling type of particles, they are those particles. Based on the size of the particles, those are discussed in the lectures. Even D-type particles, also, that like, coffee bean, those are even paddy, those are T-type particles. Their particle size would be more than 1,000 micrometer there. So based on which I think we have given that classification of the particles, and based on this classification of the particles, this fluidized pattern depends on. So also we have discussed that application of the fluidized bed. Also we have discussed how to calculate the minimum fluidization velocity. After that, froth flotation, that is also fluidization operation. It will be gas, liquid, solid systems there. Froth flotation, the particle separation by the surface creation by the bubbles there. On the surface of the bubbles, particles will be attached, and then it will be going up and to be separated. It is basically based on that nature of the particles, whether it would be hydrophobic or hydrophilic particles. Based on that hydrophilic or hydrophobic particles, that the separation of the particles can be done based on the froth flotation. And for that you need some froth developing or froth creating agents, or it is called collecting agents there. So even you need to have some other frothing agents there. So for that, what are the different type of frothing agents, collecting agents, even some pH regulator? What are those chemicals are to be used for getting that more froth? That you have to know. So that those also are discussed in a certain lectures. Okay. So if you have any doubt, you can ask here also. You can directly mail to us, or in the forum you can ask there. We will clarify. Okay. So thank you. I think yeah, you have gone through those lectures and understood the materials. And again, I am asking that if you have any other doubt, you can ask here in the forum, and you can directly mail. I think at the end of each lecture we have given that contact address, even email address, me. Then to that email you can directly mail to me and get a clarification of your any doubt. Thank you.